In this video, we're going to evaluate expressions with fractional exponents, and we're going to specifically focus on negative numbers in the base of our fractional exponent and how we deal with those and what we need to be careful of when there are negative numbers there. So before we focus on negative numbers with fractional exponents, we need to focus on negative numbers that are contained within roots. And there are two locations for negatives, and they both work a little bit differently. The first location we're going to look at is what a negative means when it is inside the root. So notice here that I have 4 negative numbers inside the root, and we're going to talk about what we do when there is a negative inside the root and how we approach that problem. So what we start off by looking at is we look at the root itself. So here we notice that we're taking the square root of negative 49. So we're trying to figure out what number squared, or what number times itself, will give us negative 49. And if I look down the squared column, I notice that 7 times 7 will give me a positive 49. So what I try to think about is, okay, what could I multiply times itself to get a negative 49? Well, the first thing I start to think of is, what if I had a negative 7 times a negative 7, something times itself that is a negative? And what I realize is that negative 7 times negative 7 is still a positive 49. So because of this even root right here, I'm going to be multiplying negative 7 or positive 7 by itself an even number of times. And what happens is, no matter what I do, the answer is always positive. So what's happening here is I'm noting that nothing times itself will give me a negative 49. This even root with the number inside that is negative complicates things. So here, because no number exists that when multiplied by itself gives me a negative 49, all I need to write is that there is no solution. Then if I move on and I look at this next one, I notice that I have a 3 here. And I notice that I have a negative 125 inside of my root. So I'm trying to figure out what number times itself 3 times will give me a negative 125. Well, I know if I look down the cubed column that I find 5 times 5 times 5 gives me a positive 125. Now I don't need a positive, so that one's not going to help. But the next thing I try is negative 5 times negative 5 times negative 5. And this one, if I start to multiply it out, I find that negative 5 times negative 5 is a positive 25. And then when I multiply it by a negative 5, it jumps back to be a negative 125. So essentially what I see here is, if I multiply negative 5 by itself an odd number of times, the answer results in a negative number. So what I can do here is I can say, okay, well, what number times itself is a negative 125? It is a negative 5. Then if I look down at part C, here I notice, okay, I have the 5th root. So I look down the 5th column and I notice that 2 times itself 5 times gives me a positive 32. Now, positive 2 doesn't really help me because that's going to give me a positive 32. But then I start to wonder, okay, what if I had 5 negative 2's? Would that work out? So here these 2 negative 2's would multiply to be 4. These 2 negative 2's would multiply to be 4. And then here I'd have another negative 2. So it would be 4 times 4 is 16, times a negative 2 is a negative 32. So what I'm realizing here is that this number of 5, I do have something times itself 5 times that gives me negative 32. It's a negative 2. And then lastly from here, if I look at my last example, here I'm trying to figure out, okay, what to the power of 4 gives me 16, and if I look down the 4th column, I find 2. Now, since it's a negative inside of here, I start to think, okay, could it be a negative 2? So I do negative 2 times negative 2 times negative 2 times negative 2. I multiply these 2 together, I get 4. These 2 together, I get 4. So I get a positive 16. So what that's telling me is that there's no way that I can multiply 4 numbers together that are the same that give me a negative 16. So there is no solution. Now, if you look very closely here, what you are hopefully noticing is that when we have an even root with a negative number on the inside, we end up getting a no solution case. And when we have an odd root with a negative number on the inside, the answer simply ends up being the negative version of what it would be if it were a positive number inside of that root. So now that we've looked at negative numbers on the inside of roots, we're going to look at negative numbers on the outside of roots. And when we have a negative number on the outside, what that's really telling us is we have a negative 1 times the square root of 49, a negative 1 times the cube root of 125, a negative 1 times the fifth root of 32, and a negative 1 times the fourth root of 16. So what we can really do is we can rewrite this as negative 1 times, okay, this is the square root of 49. And then we use our order of operations, and to remember that a root is really a fractional exponent, so that falls in the E category of our PEMDAS, so that comes first. So you would do negative 1 times the square root of 49 is 7, so my answer would be negative 7. Then from here, notice it says negative 1 times the cubed root of 125. So we have the negative 1 still. We look down the cubed column and we find that 5 cubed gives us 125. So it's negative 1 times 5, which is a negative 5. Then we look at the next one, negative 1 times the fifth root of 32. So we evaluate the fifth root of 32. So what to the power of 5 gives me 32? That's 2. So negative 1 times 2 is negative 2. Now where this starts to get tricky is when we mix it all together. So here you'll notice that we have the square root of a negative 81. So notice this is a number on the inside. So this is saying, okay, what number squared gives us a negative 81? So this is a situation where we need something times itself that gives us negative 81. So I know it's not a positive 9. And I also know that it can't be a negative 9 because it becomes a positive. Remember, an even root with a negative number on the inside isn't possible. Nothing squared, nothing times itself will give us a negative 81. So here we have no solution. Then in part B, I'm noticing here, okay, a negative on the outside. Well, that really means a negative 1 times the cubed root of 216. So then I'm trying to figure out, okay, what number times itself 3 times gives me 216. And if I look down my cubed column, I find that that number is 6. So I take my negative out in front, which is a negative 1 times 6, and I end up with negative 6. So here's answer 1. There's answer 2. Then if I look at the third one, again, I notice that I have a negative on the outside. So this is a negative 1 times the fourth root of whatever 625 is. Well, I start thinking, okay, what to the power of 4 gives me 625? That would be 5. So it's negative 1 times 5, which is a negative 5. And then lastly here, I see that I have a negative on the inside. So I'm trying to figure out what number times itself 5 times will give me a negative 1024. Well, I know that a positive 4 to the power of 5 is 1024. So then I look at negative 4 times itself 5 times. Well, this would be positive 16. This would be a positive 16. Then I have that negative 4 left. If I multiply those together, I end up with a negative 1024. So here my answer would be negative 4 times itself 5 times gives me a negative 1024. Now negatives with fractional exponents are very, very similar, but as we convert them into roots, we need to be very, very careful. So here notice that we have parentheses, and remember we've talked before about how parentheses communicate something very important. So here if we have parentheses, and then our fractional exponent is on the outside, what this is saying is that a negative inside parentheses means that we have a negative inside of a root. So inside parentheses means inside the root, and then here we would take that 2 and put it outside. So inside parentheses means inside the root. If we have a negative number outside parentheses, then that means we have a negative number on the outside of the root. And it really means negative 1 times the fourth root of 2401. So negative on the outside means negative 1 on the outside. Negative on the inside means negative on the inside of the root. So as you translate these from fractional exponents to roots, be very careful. The placement of that negative sign communicates where it goes in relation to the root. So the last thing we're going to do here is we're going to convert numbers from fractional exponents into roots, and then we're going to solve them. So here we start and we notice that we have a negative number on the outside. So as we convert this into a root, we're going to have a negative 1 on the outside. And then we have the sixth root of 64. So we're trying to figure out, okay, what number times itself 6 times gives us 64. So if we look down the sixth column, what we find is that value is 2. So we have negative 1 times 2, which leaves us with a negative 2. Then if I look at the next one, I notice here that I have a negative on the inside of the parentheses. So that means as I write this, I have a number with a negative on the inside of the root. So I'm trying to figure out, okay, what number times itself 3 times gives me negative 729. And I find that negative 9 times negative 9 times negative 9 does that. And as a result, the cubed root of a negative 729 is negative 9. Then here in this third example, I have a negative on the outside. So that means a negative 1 times, okay, 3, 1, 2, 5, and it's a fifth root. So I think about what times itself 5 times gives me 3,125. Well, that's 5. And negative 1 times 5 is a negative 5.